This is the first video for the 6.2D lesson, distance between 2 points. And you hopefully looked at the lead-in questions above this or in the Desmos activity. And I'm now going to kind of explain hopefully what you started to realize. We're going to look at a problem that has a points A, B, and C. And we want to figure out what the distance between A and B are. And we're focused on A and B primarily because distance when it's horizontal or vertical is easy to just count. We've actually been doing that. And so we're going to have point B be at x1, y1, kind of like the slope formula. So point 1 or point B. And we're going to have A be at x2, y2 or point 2. And a question that's probably quickly going into your brain, which is, does it matter which one's point 1 or point 2? We'll get to that in a little bit because we did talk about that with slope. So that would mean then that C is at the same height as B. So that would mean that C actually has B's y coordinate because it's horizontally aligned. And then it's vertically aligned with A, which means that it has A's x coordinate. And so we have a right triangle. And to find the distance between B and C, which we will need, and like I said, that's probably not that fancy, is we're just going to find the difference between the x values. And since C looks like it's more to the right, I'm going to do x2 minus x1. And I'm going to find the vertical distance by doing the point that appears to be higher minus the point that's lower. And again, we'll kind of figure out what happens if it's the other way around. And our goal is to ultimately find this diagonal distance. And so Pythagorean theorem states that we have, and we already answered these questions in the picture. Pythagorean theorem says that we have BC squared. I'm going to call it BC, which is the side length, and that's pretty common in math to do that, meaning the distance between point B and C. I'm using capital letters, so that would not be confused with multiplication. This is just the distance between those points plus AC squared equals AB. And the order of these letters doesn't matter, or BA squared. Okay, there's Pythagorean theorem. Now we're going to plug in what we know. We know that BC is x2 minus x1 squared plus, and AC was y2 minus y1 squared, and AB is what we're after. And if you remember with exponents, we did talk about that we can't distribute exponents over addition or subtraction, that we had to use like this sort of box array model. We're not going to do that in these problems today. So we'll have values for those. And then what we're going to do is we are going to square root both sides. And we're going to get this equation, kind of a horrible looking equation, and it actually cannot be simplified. We can't cancel the square and square root because of this pesky plus sign in the middle. And that is our distance formula. It is based on Pythagorean theorem. It has this gigantic square root. And then we're going to plug things in very carefully. We're going to notice that there's minus signs here and here, but a plus sign there. And we're going to follow order of operations very carefully. First subtract, keep our parentheses, then square it. Same thing here at the same time. And then once we have the sum, we will write our answer in simplest radical form. And versus having it as AB, it is common to have it with the letter D for distance, and to maybe get rid of the the capital letters that represent the points on the graph paper.